So thank you for the invitation to come and speak again at DCIO. Last year I presented but recorded, so it's nice to be here in person. I'm going to talk to you today about some once again about projects related to research we've done in the exploration of digital twins for the architecture, engineering, and construction industry. So we at Autodesk Research started our investigation, if you will, into digital twins back before we were talking about digital twins. So it was late 2009, 2010. We started to see the opportunity around gathering lots of data from sensors that were going to become increasingly ubiquitous and storing them in the cloud for later analysis. So we started by looking at the landscape of things around components around digital twins, and we decided to integrate data coming from BIM with real-world data coming from sensors or BMS systems, and then integrate tools to help make sense of this data. So this is around graphs, 3D heat maps, etc. We decided not to worry about control behavior because that's relatively straightforward to integrate, and we decided really it's more of a digital shadow, which is a term that's used now, than a full twin. And increasingly we're looking at simulations too, but we started with these three areas and really built what we've always thought of as a building debugger. So a tool that you can take lots of historical data for a building and start to make sense of how it works in order to make it more efficient. And this is the birth of Project Dasher, which started around 2010. This was at the time a desktop application that would allow you to essentially explore all this rich sensor data coming from a building and make sense of energy consumption and comfort parameters for occupants. In 2016, which is when I joined the research team, I was working elsewhere at Autodesk before then, we started to explore the use of Forge. So this is our web services platform that's now called the Autodesk Platform Services. In order to integrate this IoT data with BIM. So this was an early project that we did for NASA. That actually was quite an interesting moment for us in the life of Dasher. We showed this to the people working at NASA, and they very quickly identified a couple of areas where the temperature for this particular floor is quite different. So of course, this is the central area, which was their data center, but they also spotted this this room here that was behaving a bit differently. And somebody in the room sort of raised their hand and said, well, I think that's where we're performing an experimental glazing study. So they hadn't crunched the numbers on the data yet. It was all locked away in database tables. But we could see immediately from this visualization that there was something quite different about that room, and that it was performing differently, which was a bit of an aha moment for the project. Another project that we embarked upon for Schneider Electric was around again, a building of theirs in the south of France, and they had a new occupancy sensor. And here you can see these purple kind of Playmobil people, which show you where the people are in the space. But this gave us an opportunity to correlate the occupancy data with, in this case, CO2 data. So we could start to contextualize it even more, not just understanding the data from the sensors, but understanding what might have led to that data being measured in that way. So this was a very interesting moment as well, because we started to sort of really pursue the exploration or the contextualization of data, but also the correlation of multiple data streams. So here we can pull up a CO2 sensor for the data from a CO2 sensor in a particular room. In this case, we can see that it's that there's definitely an excess of CO2, but how often does it happen? We can easily zoom out on the graph and start to understand, well, is this a problem that happens very regularly? How can we mitigate it by making changes to the building management system, for example? From there, we started to embark on the exploration of this technology in the context of smart infrastructure. So this is a bridge in our Pier 9 office in San Francisco. We actually used this as a test project for another project I'll talk about after this one. But really, infrastructure, of course, is quite different from buildings. For a typical building, you might be measuring comfort values every minute, 5 minutes, 10 minutes, 15 minutes, whatever. But for accelerometers and strain gauges, you could be measuring them at 10 hertz, 50 hertz, 100 hertz. So it's really a different magnitude of problem in terms of the data volumes and the ingestion that you need to do. So we instrumented this bridge. We also put cameras on it so that we could start to understand the data that we're seeing relative to the use of the bridge itself. And now this was quite a good test for the technology for sure, but we quickly realized that having integrated camera feeds or video feeds wasn't ideal, because clearly, you know, there are security issues. We had to limit the number of people, or, you know, privacy issues, I would say. We had to limit the people who had access to the system because it really was not anonymized. So that was when we started our efforts around to explore the possibilities of using different techniques to you know, blur faces, to pull out 3D skeletons from video footage that we could then map back into a 3D context. And so really to anonymize this potentially sensitive person information. This is a test we did at AU some years ago. So one of my jobs in the project was to take that skeleton data and sort of map it back into the 3D context inside the Forge viewer. So this is a 3D skeleton walking along the bridge. And the overall context of this was that we were exploring all these capabilities in order to use them on a project for a startup in the Netherlands called MX3D. Now, MX3D have essentially 3D printed using robotics the world's first 3D printed steel footbridge. And the vision was always that it would be effectively printed across a canal. Now, this clearly wasn't really feasible. The context was shifted to a warehouse in NDSM Wharf, on the outskirts of Amsterdam. Also, the generative design that was proposed initially ended up being swapped out for something that was a bit more aesthetic, because this was an arts project. It was also because it was much harder to test the structural properties of a design like that. So it was more of an aesthetic design. This is again slightly artistic image in the sense that most of the bridge was printed sort of more vertically rather than horizontally, given the nature of the material. But as a new construction material, it was clearly important for us to be able to, first of all, do some testing. I mean, this is just an informal test where members of the project jumped up and down on it after a more formal load test had been performed. But we also wanted to integrate a network of sensors to get indications of the stresses on the bridge, but also how the bridge was holding up and performing. So we and other members of the project consortium spent quite a lot of time sort of wiring in a bunch of sensors into the bridge, into the structure of the bridge. The bridge itself was unveiled Dutch Design Week in 2018, and this is some of the data that we received there from the cameras that were set up at either end, where this is really just for us to test out the skeletonization algorithm that we're using. So here we can see, we're kind of matching up the skeleton data with the video footage. If you look at the sort of left-hand camera relative to the skeleton data, we can see that it's matching. So that was really just a test, ultimately with a view to taking the skeleton data and being able to once again correlate it with strain data, or in this case acceleration data that was taken from the bridge. So this was, this is an early calibration. It wasn't actually live at that time, but we were, basically trying to, figure out what the value of being able to do that. More recently, we've been able to enhance our ability to display or to extract 3D skeletons from the video footage. So these are properly 3D rather than being more or less 2.5D as they were before. We're also sort of displaying more rich, multiple streams of data using 2D heat maps as well. This is the opening of the bridge. That's Queen Maxima of the Netherlands walking across the bridge. That's actually my head. I was the one member of the project team who was based in Europe who was able to head across for the opening because it was during COVID. So that was a little over a year ago, July 2021. So yes, it's right in the middle of the red light district in Amsterdam. So it's obviously privacy is a concern there, which is why, we've invested so much energy around making sure that data is anonymized. If you do get the chance to visit, I highly recommend it. It's really a very beautiful object. There's also a website that you can go to, smartbridgeamsterdam.com, where you can see the live data coming off the bridge as you're walking across it. This project also inspired another project. So in this case, for DAR, a customer in the Middle East, they came to us and said, well, they wanted to do something similar to MX3D, but using sustainable materials. So once again, 3D printing, but also using a more generative design approach, using Fusion 360 to create the design. This was an initial bridge we did for them, which was a 2-meter size bridge. Again, 3D printed using robots. We can see sort of some of the data coming off the bridge into Dasher. So we presented at a couple of different shows. It was 2 meters long. So relatively small. It was printed upside down, so we integrated a number of FBG sensors, so fiber Bragg's grating sensors, which is essentially an optical fiber. As it displaces, you can get the sense of the strain at various points, or you get the strain values at various points. So here you can see the various sensor points, but we can also map those using a sort of volumetric heat map on the mesh itself, so that we can see that a little bit more clearly. So that gives you a sense of the kind of visualization that we were able to do with Dasher, and that we've since integrated into the Forge platform. So that was the 2-meter bridge. We went on and did a 3-meter bridge, 5-meter bridge, sorry. So this has just been displayed at Autodesk University in New Orleans. Here you can, it's a slightly different material, different scale. In this case, we really wanted to print it as if it was being, we wanted to print it at the angle that it could be printed at, going out from a riverbank across the bridge. It's a single cantilever. For printing, and it had to be self-supporting during the printing process. But then when it's actually in use, the idea is that it will rest on the other bank as well. So essentially, it's supported on both sides. 5-meter span, about a metric ton of material. The material itself is PETG, so recycled PETG with fiberglass reinforcement. We had it on display in New Orleans, as you can see the top right image there. We had on, the screen there was showing live data coming off the bridge. It took about 200 hours to print. We used heat lamps to make sure that the existing material was soft enough to bond with the new material. Very interesting project. We haven't, I talked about infrastructure. We haven't, stopped working on more building related projects. So we've worked with the Nest building on EMPA's Dubendorf campus as the Swiss Material Sciences agency alongside with ETH Zurich. So we've been taking data from that from that building. Essentially, we have a digital twin of that. If you go to dasher360.com and click on demo, you get access to this same this same demo. It was sort of, in this case, we're showing multiple heat maps, as we can, play it with the timeline to explore the data coming off various sensors at the same time for the whole floor of the building. So these capabilities in terms of the visualization that we've taken have been built into the Forge platform, or the Autodesk Platform Services capabilities. There's an extension for the Forge viewer that allows you to visualize data via heat maps, just as we've done inside Dasher. That has also been picked up by the Autodesk Tandem team. So they've been very much focused on digital handover from BIM, from different phases of the life cycle. But they're now looking at getting operational insights from that data. And so this is an early view of what's coming. There's a beta that you can sign up for now. For Autodesk Tandem, and you can see here where they've got sensor data for various sensors, various sort of pieces of equipment, or physical sensors inside the space. They're also able to display heat maps using the same capability as we built or we prototyped using Forge. So definitely worth looking at if you're looking for technology to sort of display data in this way, either using Forge or as an end user of technology using Tandem. So while this work is ongoing and very much, we're still in the early stages relative to Tandem, inside research, we're continuing to focus our efforts on digital twins, but really in terms of how we can close the loop on the design process, taking the data from real-world performance and feeding it back in to the design loop, whether from a generative design perspective, where it's more algorithmic design, or using a more traditional design process where people are influenced by the data that's been collected in the real world. So we can really sort of iterate and create more and more optimal versions of designs over time. And with that, as a brief bibliography, and thank you very much. Here are my contact details. Please feel free to reach out and to let me know if you have any questions about this. I'll be happy to answer them. Thank you.